This video is going to look at what happens when we're working with definite integrals. So in the last section, we looked at the principle of substitution, sometimes called use substitution. We looked at how it applies to indefinite integrals, how it just finds the general solution. And now we're going to look at how we find a specific solution if we identify the bounds. So there's two approaches to this, one of which is kind of the way that we already did it, just treat it like an indefinite function. But the first one that we're going to talk about is actually that generally the bounds of your function must also be changed. So in other words, if you go from the integral from 1 to 0, you have to check those to make sure those, you have to change those to deal with the u's. But if you prefer and you have the information and the integral is actually solvable, you can just treat it as an indefinite integral, find the antiderivative, use the fundamental theorem of calculus, and plug things in at the end. I'm not going to show you an example of that because that's in the last couple videos, but we will look at this kind of first approach where we change the bounds. So, sorry, that was going backwards instead of forwards. So here's our example. If we're integrating from 0 to 1 of x times the square root of 1 minus x squared dx. So we can look at this, and hopefully by now you can pick out this 1 minus x squared as your u. So that means that u is equal to 1 minus x squared. So du by dx is going to equal to negative 2x. And that means that our dx is going to equal to du over negative 2x. So let's substitute that in, just like we were doing before. So x times the square root of u du over negative 2x, and then our x's will cancel. Now, this 0 is actually telling you from x equals 0, and this 1 is actually telling you to x equals 1. But our integral is now in terms of u. It's from u of something to u of something else, because u is not equal to x. So we need to figure out what those are. So u of 0 is going to equal 1 minus 0 squared. U of 1 is going to equal 1 minus 1 squared. And that's just looking at this function over here. So u of 0 is equal to 1, and u of 1 is equal to 0. So oddly enough, that actually just flips our bounds here. That's not always the case, but in this instance it is. So now we're integrating from u equals 1 to u equals 0, because those are the equivalents to the x equals 1 and the x equals 0 from before, because we plugged them in to this function up here. So that means we're resulting with the integral from 1 to 0 of the square root of u times negative 1/2. I'm just going to pull that negative 2 out front, du. So then that's going to be equal to negative 1/2 times the integral of u to the 1/2. Well, we'll be extra thorough with this. U to the 1/2 du, which is going to equal negative 1/2. Add 1 to the 1/2, so that'll be 3/2 divided by that, so we get times 2/3, u to the 3/2. And then we're going to integrate that from 1 to 0. So those are our upper and lower bounds. So we get negative 1/3 times 1 to the 3/2 minus negative 1/3 times 0 to the 3/2, which will end up equaling negative 1/3. Did I do that right? I did not do that right. This should be 0 because that's our upper bound, and this should be 1 because that's our lower bound. So it should be positive 1/3 as our answer. So that's the example doing the bounds change. The no bounds change would be just rewriting this as instead getting, where were we? -1/2 times 2/3 u to the 3/2, and then plugging back in our u at the end. So -1/3 times 1 minus x squared to the 3/2, and then using the original x equals 0 and x equals 1 bounds. So you can do this, it's totally fine when you get to the end to take that u and plug in, what it was in terms of x. That's generally my preference because I feel like it's fewer steps for me. But there are multiple choice questions on the AP test that ask you, or are testing, do you remember to change your bounds when you rewrite the definite integral? So that's integration with substitution when we have to change the bounds.